Let's move now to the examples part of our discussion on impulse and momentum, wherein we look at a couple of problems or examples. So consider the following problem. You have a 10-kilogram drum is sliding along a slippery surface at 5 meters per second as shown in the figure. The man standing on a ledge, 60 kilograms in weight, hops on the drum as it passes below him. Determine the final speed of the man as he rides the drum. In this problem, you have two objects, the drum and the man. Let the drum be object 1, so M1 is 10 kilograms, and the man is the second object, M2 is equal to 60 kilograms. According to the problem, the drum M1 is traveling at a speed of 5 meters per second, so let V1 initial be equal to 5 meters per second. And since the man is just standing on the ledge initially the man is at rest, V2 initial is equal to 0. When the man hops on the drum and rides it, both he and the drum will have the same final speed, so V1 is equal to V2. Let that just be equal to V. Now, conservation of momentum tells us that the initial momentum is equal to final momentum. Initial momentum, the drum is moving at 5 meters per second, the man is just standing on the ledge. Final momentum, the man is on the drum and is riding it. They both have the same final velocity. So initial momentum, you have two objects, M1 and M2, so you have P1 initial and P2 initial. Final momentum, you have again two objects, P1 and P2. So conservation of momentum tells us P1 initial plus P2 initial is equal to P1 plus P2. Momentum is mass times velocity, so expanding our momentum to their equations, we get M1 V1 initial and P2 initial. V2 initial is 0, therefore P2 initial is 0, so plus 0 is equal to M1V plus M2V. Now, we're talking about vector quantities here. So we need to use our vector analysis component method. The motion is just along the x-axis, so no y component. We can go directly to the x component. So x component, the only unknown is v, so we can isolate v, and we get m1 over m1 plus m2 times v1 initial. Plotting in the values, we get the answer for our problem. V is equal to 0.714 meters per second. Next, we have the following problem. A 1 kilogram box slides along a rough horizontal floor. It starts with a speed of 4 meters per second and comes to a stop after sliding for 5 seconds. With this information, what is the coefficient of kinetic friction between the box and the floor? Okay, so here you have only one object sliding on the floor. M is equal to 1 kilogram. Initial velocity V naught is equal to 4 meters per second. The box eventually comes to a stop. So final velocity is equal to 0. The box is sliding for 5 seconds. So T is equal to 5 seconds. So clearly something has caused the velocity to change. Something has caused the momentum to change. And in this particular problem, it is due to kinetic friction that the momentum has changed. So there is an existence of an external force causing a change in the momentum of the system. So conservation of momentum equation, we use the following. Initial momentum is equal to impulse due to the net force is equal to final momentum. Again, initial momentum plus impulse is equal to final momentum. And the impulse is due to the kinetic friction. So, integral of f sub k dt. Initial momentum plus integral of f sub k dt is equal to p. Now, kinetic friction is constant or relatively constant, so we can bring it out of the integration. So basically, we are just integrating dt, which will give you t, expanding our momentum to mass times velocity, we get the following equation. mv initial plus f sub kt is equal to 0 final momentum being mass times final velocity. Final velocity is 0. Our equation, again, rather, a component method, all our vectors in the equation are horizontal, so only x component. So we go directly to the x component. There is no y component. V naught is horizontal, positive direction. Friction is negative direction, opposing the motion. Friction, we know the magnitude to be mu k n, where n is the normal force magnitude. So our equation becomes mv initial minus mu k n times time is equal to 0. Now, for an object simply on a horizontal position, on a horizontal surface, the normal force magnitude is just equal to the weight magnitude. So n is equal to mg. mv initial is equal to mu k mgt is equal to 0. Isolating mu k, we get mu k is equal to v naught over gt. We cancel out the mass m. We get the following answer. Mu k is equal to 0.082. Alternatively, we can use our net force analysis and kinematics. There's enough information for you to perform kinematics and get the acceleration. And then using that value of the acceleration and net force analysis, you'll be able to get the answer for the coefficient of kinetic friction. And that's it for now. We'll continue our discussion in the next video, which covers collisions.